Okay, guys, this is the last lesson of chapter 11. We do have two different review assignments that are worksheets that look an awful lot like your test. So make sure you do those review assignments because those will be really beneficial. And I'm going to talk you through the entire second review assignment. So if you want to watch that video and do it along with me, that would be really helpful. Okay, 11.7 is area and volume of similar solids. So first thing you need to know is what are similar solids. And those are figures that have the same shape and corresponding dimensions that are proportional. Okay, so same shape, as in one is a cube, the other one's a cube, or one is a rectangular prism, the other one's a rectangular prism. But then there's corresponding dimensions or corresponding sides have to be proportional all the way through. Okay, one thing to note, all cubes will always be similar and all spheres will always be similar to all spheres. So just a little fun fact for you. We don't need to do anything with that. But here's what we're going to do. First example, it says, are the figures similar? If so, give the scale factor. And then just keep in mind, scale factor always compares dimensions, the side lengths of things. Okay. So first you look at, are they the same shape? Yes, those are both rectangular prisms. Okay. Then you have to check, are the sides proportional? So I'm looking at 3 corresponding to 6. Does that equal 3 corresponding to 6 and 2 corresponding to 4? Okay, so if you notice, this is 1 to 2 and 1 to 2 and 1 to 2. Well, because they are proportional, right? They have the same scale factor, or well, yeah, we're going to call it scale factor. Because they have the same scale factor, then we would say, yes, those are similar figures. So are they similar? Your answer is yes. And your scale factor is 1 to 2. Okay, so this would be your answer. Okay, look at the second one here. The question is, are they similar? If so, give the scale factor. So now we're going to say 2 to 3. 3 to 6. And 2 to 3. Well, notice 3 to 6 is a 1 to 2 ratio. So these are not equal. So when they ask, are these similar? We would just say these are not similar. You don't need to give a scale factor because there isn't a scale factor because they're not similar. Okay. Okay, so something to keep in mind. We kind of have done this before. We did the scale factor, and then we did perimeter ratio, and then we did area ratio. Do you remember that last chapter? We're going to do a very similar thing this chapter, but now it's going to be scale factor, still area. Remember area, we squared it, but now we're also going to have a volume ratio. Okay, so here's how it works. If your scale factor is A to B, then your surface area takes those two and squares them both. And your volume takes those two, not these two. You take these numbers. So you take your scale factor and you cube the scale factor. And you get A cubed over B cubed. Okay, so let's just try it with some numbers so that you know what I'm talking about here. Let's say we have a scale factor. Oops, that's not a pen. Let's say we have a scale factor of 1 to 2. Okay, that means that our surface area ratio is 1 squared to 2 squared, and it means our volume ratio is 1 cubed to 2 cubed. Okay, that means my scale factor is 1 to 2, My surface area ratio is 1 to 4, and my volume ratio is 1 to 8. Okay, so that's the relationship between those three every single time. Okay. Okay, so let's say instead of giving us a scale factor, we're going to find the scale factor and they give us the volume ratio. Well, if they give you the volume ratio, you have to think about what has happened to it. Okay, a volume ratio is some number cubed over some other number cubed. Well, if I want to get just to this, get rid of those cubes, I need to cube root, right? So if I take 3,375 and 1,728 and I cube root both of those, so the cube root of this and the cube root of that, I should be at my scale factor, okay? Again, from yesterday, how do you plug this into your calculator? You're going to do a 3, and then you're going to hit the button that looks like this, and then you're going to plug the number in, 3,375. If you have the graphing calculator, you hit math 4, and it cube roots for you, okay? So cube root of 3,375 is 15. Okay, cube root of 1,728 is 12. Is that your scale factor? The answer is no. What you do to find a scale factor is you have to reduce. So 15 over 12 would actually reduce if we divide both by 3 to 5 over 4. Okay, so your scale factor, if your volume ratio was this, then 5 over 4 is your scale factor. Okay, so you would just cube root everything. You could reduce this first and then cube root it, or if it works out nicely like it did here, you can just reduce at the end. But if it's working out to weird numbers, try reducing it first and then take the cube root. Okay? So that's example 2. Example 3 is this one. And what this says is the volumes, okay, the volumes, they're giving you volume here, of two similar solids are 40 and 135 cubic inches. If the surface area of the smaller figure is 48 square inches, what is the surface area of the larger figure? So we're going to set up a proportion here, okay? We know right now that our volume ratio is 40 over 135, okay? But like I said before, reducing is huge in this. So what we can do, we want to reduce right off the bat here because the cube root of 40 is not a nice number. If we reduce these, divide both by 5, we get 8 over 27, and those numbers are lovely to work with. Because it's a volume ratio, a cubed over b cubed is our 8 over 27, right? So what we're going to do is we're going to cube root both of those. So the cube root of 8 over the cube root of 27 is going to be our scale factor. Okay, well, when we cube root that, we get 2 to 3. Okay, so that's a scale factor. And a lot of times people stop right there and set up their new proportion. But notice what it says. It says if the surface area of the smaller figure is 48, find the surface area of the bigger. So we don't want a scale factor. We want an area ratio. So our area ratio would be if we took that 2 to 3 and we squared it, right? That's how you make a scale factor, an area ratio. So our area ratio is 4 to 9. Now we can set up a proportion. So our proportion is going to say 4 over 9 equals something over something. And look at what they told us. The smaller figure has an area of 48 square inches. So does that go on top or on bottom here if it's the smaller figure? It's going to go on top, right? Because the smaller over here is on top. So we're going to put an x here, and we're going to cross multiply. We get 4x equals 9 times 48 is 432. And then we're going to divide by 4. So we get x equals, this comes out to 108. Remember, we were solving for area. So it's 108 square inches. I love that problem. So fun, right? So fun. Okay, last one. Example number 4. It says Office Max sells paper clips in small and large boxes. A small box holds 220 paper clips. Now think about what that means. A box holds 220. That is volume. And then it says the large box is formed by doubling the dimensions. Okay, dimensions, whenever they're talking dimensions, that is more a scale factor. Okay, dimensions aren't volume anymore. But they're asking you how many paper clips should fit, volume, in the large box. Okay, so let's think about what we know. We know that dimensions are doubled from the small box to the large box. So we're going to start with a scale factor. If we are doubling dimensions, the dimensions would work as 1 to 2. Okay, small box, large box. If that's our scale factor, we need a volume ratio. How do you make a scale factor a volume ratio? You cube them both. So we're going to cube 1 and we're going to cube 2, and we will get a volume ratio of 1 to 8. Okay, so now look at what they're asking you. How many paper clips, volume, will fit in the large box if we know that 220 are in the small box? We're going to set up a proportion. So 1 over 8 equals, where is that 220 going to go? If it's the small box that holds 220, it's going to go across from the smaller number. And then x is the volume of the larger box, and we'll cross multiply that. So we get x equals 8 times 220 is 1,760, and we were talking paper clips, okay, in the large box. Okay, that is it for chapter 11, guys. Hopefully you are feeling good about it. Definitely stop by my Zoom if you have any questions from any of it. I will do another one beginning of next week as well, but yeah, I just want to make sure that all your questions are getting answered. Okay, hopefully I will see you in our face-to-face time.